Previously, I made a video or a couple of videos showing how to fly manually and capture drone photos for photogrammetry uh, with an Air 2S in my case. Now I'm going to show how to edit, and I use Lightroom. Your process would be pretty much the same if you use one of the alternative programs. But so you start with your raw files. I've got my DNGs imported. And so one thing is, if you look down here, you see my file names. When I import them, I apply a profile to have them named by year and month, date, and time. So you can find videos on YouTube of how to do that, but it helps you keep track. You can see from the name exactly when and or when you took the picture and everything. And another thing is that with these drones, these numbers will repeat, and often they'll repeat within one day if you use different SD cards, because it'll start over from 001. So it gets confusing. If you have them like this with your year, month, day, and then the time, hours, minutes, seconds, then they go in order by time just from the file name. If you sort alphabetically, and then you can see when you're doing your processing, your editing, all that stuff. So anyway, another thing, so I always start with one photo on the roof of the car where I launch from, or the ground. Just to have a reference of the height values, because sometimes height or altitude can be wonky on DJI drones, and probably other brands too, but the altitude value, sometimes where you launch from is 0, sometimes it's actual altitude. And so in this case it looks like 705.1 feet. That is probably the actual altitude of where I was flying from. So that's good to know. You can always check on Google Earth to get altitude values and see if it's accurate or whatever. So in this case, the ground is probably about 2 meters below where I launched from, which is the roof of my car. So maybe 703. I could check Google and see what that value is. But anyway, so to edit, you go to your develop, and then you want to do Control A to select all, because you want them all to be edited exactly the same. And one thing is, I try to get white balance. So that's one thing about the roof of the car, is I can get white balance from my roof rack. But that looks green, that doesn't look good. I'm gonna try this part. That looks better. Still kind of looks a bit off, but we'll see once I do the other edits. Usually I start with exposure, and so that's one good thing about RAW, is you have a lot of leeway to change your exposure, increase your exposure. And I found it's better to shoot a little bit dark and then brighten. If it's overcast, especially, because if you were to try to get this exposure, you would be either decreasing your shutter speed, and it's already at 1/500th, which is as low as I want to go in case there's any camera shake or trees being blown by wind and stuff like that. So 1/500, and then ISO 400 is as high as I would go on a drone like this. The Air 2S has a 1-inch sensor. If you're using a DSLR and you're shooting from an airplane or a helicopter, you can go higher than that. But with these little drone cameras, that's about as high as you want to go. You can see even at that ISO 400, there is noise. So you can see on these kind of uniform color areas, there's kind of a speckly effect. And that's just camera noise, it's not actual texture. So anyway, I got my exposure a little bit higher, and I usually increase my shadows so that you get more detail in areas like that and like that. So I go up on the shadows, not too much, but you go about 20 or 30. And again, update all of them at once. Oh, and then in order to have them actually update at once, you need this auto sync. If you have that off, then it doesn't update all. You have to click sync. So make sure that switch is flipped. Another thing I like to edit, especially when it's overcast, is saturation. And you don't want to go too high, but about 30. And you can see there's some differences now visible in the trees. Some of them are brighter, some of them are duller. And then the edits ripple through your previews. Your sharpness, in Lightroom the default now is 40. That's a little too high because, like I was saying, in these kind of areas there's noise and that noise gets sharpened. So let's see what happens if you turn it up. That's clearly too high and you're just really making the noise worse. And then the 40 is too high, I found. So I go down usually. Let's go to 30. Yeah, you get a good amount of detail, like on these edges. But the noise is not too bad. I mean, you can also do noise reduction this way. It kind of makes the image muddy. Oh, what the heck, I'll do 10 noise reduction. And make sure you don't have any profile correction set. You want to minimize the amount of correction done by the software that you're editing in, because photogrammetry programs want data straight or without any of that correction. Like if you have a fisheye photo, it wants the fisheye. If you have a GoPro, it wants the wide, fisheye view from that, because it calculates those corrections itself. And so if you give it already corrected data, then it has trouble. It can't really do that itself. Now with DJI drones, there is a lens profile applied, and I have not found a way to get rid of that. Built-in lens profile for chromatic aberration. So I guess it doesn't change the distortion, it just helps with chromatic aberration. So that's good, I guess. I haven't had any issues with it. So let's see. You can also change colors to try to get them to look more accurate. These sliders are really good, the calibration sliders, and I usually just do this blue one. To me, that looks more accurate. The greens look more like they really are kind of mossy olive green versus like super bright. So yeah, that's one slider I like. It helps vegetation, I think, look a lot better. But that's up to you. It's also going to vary a lot depending on your monitor. So what looks right to me may not look right to everyone else. And this is a calibrated screen I'm working with, but it's not perfect. Anyway, exposure, I'm just going to go to +1 exposure. And you can look at your histogram up here. And on this end is white and this end is black. And so as long as you don't have too much white or too much black, it's kind of okay. You want to be in the middle, but it depends on what your subject area is. Like if you had, so it varies, you can see it varies by photo. And red, green, blue are all different. Some of them actually are quite a bit brighter. So maybe the sun moved, so it was going through less cloud cover later in my flight. So you can try to adjust those manually and get them to match up, but it's super labor intensive. For now, I'm just going to leave them as they are. So I already have them all selected. If you want to deselect, you can do Control D. But I'm going to select just the ones I actually want to do my photogrammetry on. So not including the refract. I'm going to select the first one, scroll over, hold down Shift, and then right click, export. And then I previously exported these, so I'm just going to choose the same folder. And I don't need to rename because they're already named, but this is where you could apply your naming conventions. So you could do like date, file name, date, time. I think that's my custom one. So you can see that's how I set that up. Yeah, this is my custom. So it's kind of clunky. You use these menus to put in your options. So like you would choose year to put in the year, and then hit insert, and then month, date, and then so you build it out with your year, month, day, and then hour, minute, second, and then the original file name. So you could just duplicate what I did here for my naming convention. I'll probably put this in the YouTube caption or the YouTube comments. So anyway, I don't need to rename. I already have that naming. And then I just do JPEG. There's not really any benefit to doing TIFF. Even though you can do 16-bit, it doesn't, maybe if you did Adobe RGB, but I stick to sRGB anyway. But this doesn't give you any more depth, like it doesn't give you ability to bring up shadows or anything like that. So you get more color gradations, but it's within the same range if you stick with sRGB. So I just do JPEG 80. And then for archival, if you want to archive your files to be able to edit later more, if you do it this way, if you export DNG, you'll get your raw data plus the edits will be saved in that DNG as metadata. So that's a good way to archive. You export out to a external hard drive or whatever. JPEG, no resizing, no sharpening. You don't want to add any more sharpening. And no watermark, and you want all your metadata. That's very important. Do not remove any info from that metadata because you need the GPS coordinates. So do export overwrite all my existing ones. That's pretty much it. You just wait for it to finish. And then the next part is to bring those photos into your photogrammetry program. Next step after you export your photos from Lightroom or whatever photo editing software you use is to actually load them into your photogrammetry program and then do the photogrammetry. I use Agisoft. I've tried a lot of different ones, and this is by far the easiest. It's not especially easy. The interface is clunky, but it's way better than the other ones. So let me get started. Your main tasks are going to be under this workflow menu. So the first thing, you can see the different steps. First thing is add photos or add folder. So I'm going to add folder, and then I'm going to choose the folder that I exported my files into, ridge_demo, and then it gives you this option menu. Usually you'd use single camera. There's other options. I think it's for if you use like multiple, if you use like tripods and put cameras onto tripods, I think you would want to set them up so that each location has its own camera basically when you import. I'm not sure exactly, but generally you do that single if you're just doing drone photogrammetry. So, and there they are. And now I didn't intend to put the one from the roof of my car, so I'm going to remove that right now. So you right click and then you do remove cameras, remove one camera, yes. And so it's always good to scroll through and check if you don't have any other ones like that, like maybe flying back to land or whatever. So yeah, those are all photos I want. So you need to set up your camera calibration. So you go to tools and then camera calibration. And so this is, you choose your camera on here. So if you have multiple cameras, you would have them in different groups in here. I just have photos from the one drone in here, so they're all in this group. And the main thing is rolling shutter compensation. This is for if the drone was moving when you took the photos. Like if you're flying the drone in a path, like you're going straight and then you turn around, you fly back, and then you turn around, fly back, and turn around, fly. Rolling shutter is the distortion caused by the shutter readout. So let me see if maybe I can do a demo of that right now. So this is video, and so it should have, when I go like that, there should be distortion of my face where it looks slanted because the sensor is reading out slower than, the time of a frame of video. But basically it's a type of distortion that you have to correct for. And so if you have the drone flying forward, you would use that regularized option, and it'll correct for that kind of rolling shutter. If you're doing like an automated flight, or maybe you're not that careful about how you fly and take the pictures, you'll have shots where the camera is not just going in a straight line, introducing that kind of rolling shutter distortion. You'll also have the camera going in a straight line and staring, rotating, and then flying straight. So you have to correct for that also, and that would be where you would use full. And that does have its own limitations. So you would think you could always just use full, but if the camera is stationary for each shot, it's better to do disabled, and that way the software knows it doesn't have to do that kind of correction, which is the case here. If you've got mixed photos, like some of them are stationary and some are moving, then you need multiple groups. So you would select your photos in here, like let's say my first 5 were stationary. I would select those and they get selected in this dark gray. It's kind of hard to see. You right click, create group, and that puts them in their own group. And then you can rename that to stationary. And then you can have the other one be rolling. And then you can change your settings. You could have the rolling ones be regularized and then the stationary ones be disabled. And that way it knows, can do a better job. Because it's basically matching the photos up to each other. So it's taking all of that into account, whether it needs to correct for rolling shutter, whether it doesn't, things like that, when it's trying to align them to each other. And it's like it's aligning, I think, every photo to every other photo, or trying to. So anyway, we don't need these multiple groups. So let me see if I can shift control or shift click and then right click merge groups. I'm going to rename stationary is fine because they are stationary. And there's other options. I think you can change each red, green, blue band. I'm not sure how exactly you would do that. Like you can see there's 0, so maybe you can change your black level to exclude blacks. I don't know. Exclude grays. Make grays into blacks. I've never used this ever. You can do offsets. I haven't figured out how to do offsets because that would help if you have inaccurate elevation or altitude. But I've tried and I haven't gotten that to have any effect. And I've asked on the forums and I haven't gotten a good answer. But you can always experiment and try and figure that stuff out. So anyway, the main thing is these are initial settings, and then once you do the alignment, this tab will have stuff in it. It won't be grayed out. So anyway, next step, save your project, of course. So it's Ridge Demo, and then workflow again, align photos. So it's going to align them. High uses every pixel. If you do medium, it'll basically cut down each photo to half resolution. So like if your photos are 6,000 by 4,000 pixels, it'll resize them down to 3,000 by 2,000 and then do its alignment. And so that speeds it up. But I'll always do high. If you do highest, it'll interpolate and double the resolution, which seems useless to me. So I just do high. And then I think these options have to do with the order you take the photos. I think it'll try to look, if one photo comes after another, it'll try to align them. It'll try to align those, and then it'll move on to the next one. It won't look at every single photo and try to align it to every other photo. I'm not 100% sure on that. The key points are the number of locations on the photo, on each photo that it looks at to try to create matches. So it'll identify 40,000 places, and they're not individual pixels. It'll be looking at patterns. And sometimes those are patterns that are not obvious to humans. Like it'll be a random patch of concrete that we would never notice. It won't be the manhole usually. It'll be it'll be just an area of concrete, or dirt or vegetation. And so it'll look at 40,000, and then the tie points are the actual tie points between photos that it'll match up. out of those 40,000. I'm not 100% sure if what I'm saying is accurate, but that's my understanding from reading the documentation and the forums and all that. So anyway, you can ignore these options. Adaptive camera model fitting, I think it'll choose some of the distortion corrections for each photo and not necessarily use all of them. I'm not sure what the point of that is, because it kind of does that anyway. But anyway, these are the settings I use. And sometimes if it's a large set, I'll reduce that to 20,000 and reduce that to 2,000. And it seems to work fine. But for this project, it's only 77 photos, so I'll leave it on those defaults. And let it run. It'll take about 2 minutes. And then you can see your CPU usage is pretty high when you're doing this, and also your GPU usage. Well, no, it's only 45. I think this is a 175 watt graphics card. It's only pulling 40. So this part's using a lot of CPU, less graphics card. There's the CUDA usage, that's your graphics card. So it uses graphics card for some tasks, CPU for other. And this is kind of an old workstation, but it has a 8-core Xeon. By modern standards, this one is not that powerful, but it works pretty well for this. And I have 64 gigs of RAM. My usage didn't go that high, but it does if you have large sets of photos. So anyway, now that this part's done, I can save. And so it has created a point cloud, like a really simple point cloud in 3D. And let me turn on those are the positions of the photos. And that's how you turn them on and off. Slave cameras. I don't know what that means, but anyway, so if you hold down Shift, so each of these squares is a photo and the black line represents the angle. If you hold down Shift and turn your mouse wheel, you can make those smaller. And you can see I basically did 2 orbits. When I was flying, I thought I was getting more angled shots perpendicular to the slope. But it's kind of hard to gauge that kind of thing when you're flying, especially in these really hilly environments. So I could have gone lower, flown lower to capture this part. And I could have gone, I could have probably shot straight at the slope and then moved down and back and then down and back and gotten a good set that way. But so lesson learned. But there's enough angles that this looks like a pretty good 3D representation. And so if you look at the photos, so you double click on a photo and it'll select it, or it'll go to that photo and show it in your full view, and that creates a tab. Then you can go back to your model with that. So that's the 3D model, and then you would click that again to go to your photo. One thing is you can see the those points that it used to match. So I think that's the 40,000. And I'm not sure what the white and blue mean. Maybe the blue are where it found matches, and the whites are where it didn't. So you can see, like, maybe it looked here and it saw a pattern there and then matched that to another photo. Probably, yeah. So it matched this kind of area there. It didn't match this one. There's that blue. So that's basically all the matches it finds, and that's also what makes up this point cloud. So that's all the matches. So it's basically finding those matching points between photos and then positioning them in 3D space, and somehow aligning all of these photos using those points. So anyway, I don't have ground control points, but this is the step where you would add them, and I'll go into that in another video. But for this, let's just use the GPS data, and you can see every photo has GPS, latitude, longitude, and altitude. Now, I think the EXIF data said 705, maybe that must have been feet, 705 feet. And then the altitudes on here are in meters, and that was when I was out on the roof of my car, 705 feet on the roof of my car. So that's about 200 and something, 250 meters. So I guess it would make sense that the flying altitude would be 406. And then that 10-meter accuracy is just standard. It just assumes 10-meter accuracy for GPS. And it shows you an estimated error of alignment of all of those. This is not your error in space. Like, you can't say each of these or everything in this 3D model is half a meter accurate. That's not what that means. That's not what that total error or these errors for each photo mean. This is just estimating. It's basically showing how well it was able to align them with one another, and then comparing that to the GPS and the altitude. So anyway, once they're aligned like that, you can if you add control points on the ground, like positions that you have GPSed accurately or surveyed, you can add them with that tool or with that button, and it lets you choose a CSV file. So they have to be laid out a certain way. And then you would press this star. So this is to load the ground control points, and then this is, that star is to realign them. And then I always choose every option. And then there's no realignment to do in this case, so it didn't do anything. It didn't change anything. And anyway, so once they're aligned and then realigned, if you do the control points, you go to workflow again and then do build dense cloud. And then again, you can choose quality. High, I think, will turn every pixel basically into a point. And so, like, that's basically the default. Depth filtering gets rid of points that look like errors. Like, if you look at this, there's a lot of these little individual points. A lot of those are probably not, it's just errors in the processing. And so we'll get rid of those. And so the default, I think, is mild. And so we'll keep a lot of those. Moderate, we'll get rid of more. So it might get rid of some of the vegetation, which might be okay. Aggressive will get rid of a lot, so you might lose a lot of the tree foliage, but that might help if you want to expose the ground more. But you kind of have to experiment and see what works best for your particular project. I'm going to do moderate. I usually start with the moderate. And point colors is like that. It assigns colors to every point. Point confidence, I guess, does statistics for every point on how confident it is that those are accurate, but I've never used that. So anyway, high and moderate, hit OK, and it will create the dense cloud. After it's run, you don't see anything different. You have to switch from the point cloud to the dense cloud. So you hit that button, and that's the dense cloud, and you can turn off your cameras to get a better view. You can rotate, you hold down middle mouse. By default, there's like a sphere that appears in the middle that you can drag to rotate. I don't like it, so I turned it off. But if it is there, then you can. Let me see if I can turn that on right now. Preferences. Navigation. Oh, I can't find it. Never mind. But so this is your dense cloud, and a lot of it you'll find that you don't need. So what you can do, you can select points, and one thing that helps, so this view is a perspective view. You can see there's perspective distortion. If you're looking straight down, the bottom of the box is smaller, and then the top of the box is bigger. If you press 5 on your number pad, it switches to orthographic. So you're looking down into a box basically, but the top and the bottom of it are the same size. So there's no perspective distortion. And then if you rotate your view, it kind of looks weird. It's kind of like if you're first learning to draw and you don't know about perspective yet. So the front of the box and the back are the same size, so it looks weird because you're expecting perspective distortion like that. You're expecting the back to appear smaller, so it looks wonky. But what that does, it lets you select easier. If you have a area you're concerned with, you're interested in, and you want to get rid of the rest, because it's straight down, you can select pretty easily using that tool, the select tool. So you can drag, and I'm going to get rid of a lot of the surrounding vegetation. So you drag, it turns pink, and then you can press delete. Drag, turns pink, press delete. Drag, press delete. Drag, press delete. So now it's a lot cleaner, easier to view. And this is just the dense cloud. This is not the final 3D model, but this is going to affect the next steps when you create the 3D model or the DEM, all that stuff. You can do two things. You can create a model, 3D model, or you can create an elevation model and an orthomosaic. So I'm going to do the orthomosaic first because I'm a GIS person. So I'm going to go to your workflow and then build DEM. And then I do everything in WGS84. You can also use like UTM or state plane or whatever makes sense for where you are. Because we're in the tropics and we're close to the equator, there's not much distortion from just using the plain geographic, which is Mercator. If you're close to the poles, you get a lot of like horizontal distortion. But down here in Hawaii, we're okay with WGS84, and that also fits if you're uploading to Arc Online. WGS84 geographic 4326 makes sense because that matches ArcGIS online tiling system. So unless you have a reason to use another one, then just use this. So anyway, once you open that tool, it'll show you the resolution and stuff like that, which is going by this point cloud. So it kind of knows how much information there is and what kind of resolution it can get. And the source is going to be the dense cloud. Interpolation enabled. I think that'll fill in holes and stuff like that. So you always want to enable that. And then that meters, that's 4 centimeters. So that's pretty high res. And hit OK. That step's pretty fast. So it only took a few seconds, really. I'll save your project, and then to view that, so right now we're on the Model tab, but we're going to switch to Ortho. And there it is. This is like a color representation with hill shade. So you can see those shapes, you can see a lot of the branches and stuff. But that's, you know, a DEM elevation model. It's not bare earth, it has the trees and stuff. But what's cool is that in the lower right there, it shows you your coordinate system, your lat long, and it shows your meters, your elevation. So as you hover over, that updates on the fly. So like that little ridge there is 325-ish. Down here is 319. Up here, 330. So you can get an idea across the slope is 10 meters or 30 feet. And up here is 340. So, and then you can look at trees too. So if the ground here is 329 in that lower right number, and then this tree is 336, 329, 336. That's 7 meters or about 21 feet. Let's say 20 feet. So that's pretty cool. You can measure stuff just with that DEM. That'd be good for building heights and stuff like that. So anyway, once you have the DEM, you can build the orthomosaic. So you go to workflow again and then build orthomosaic. And it's kind of the same pop-up, and it shows estimated values, pixel size, etc. I don't think I've ever noticed this before, but the X and Y dimensions of the pixels are different. And that's 2, I don't like the scientific notation, but I think that comes out to 2 centimeters. Oh, it's in degrees because it's WGS84. Okay. Or is it meters? Interesting. So again, this is about, it estimates that, or it figures that out based on how much data it sees, and this is usually twice what the DEM was. You remember that was 4 centimeter and this is 2 centimeter. So just leave that as what it is, and surface DEM. So it's using that DEM and then it's creating a mosaic. And you'll get hole filling. This option, refine seam lines, it'll try to place as it's piecing together these images to create an orthomosaic. It's literally like a mosaic, like each piece is like a tile in a mosaic. But if you do refined seam lines, it'll put more effort into where those lines go, so that objects and patterns and things don't get divided. It'll try to put the lines where it looks like there's nothing important, but it takes a lot longer, so I usually don't use it. Ghosting filter gets rid of things like cars, because you have overlapping images. If you've got cars driving by, it'll try to blend those cars with other images that it has to make them transparent or make them disappear. I usually don't use it. It adds additional time. And on a ridge, you don't need it. There's no cars and there's no, you might have animals walking around and you would probably want to see them. Like, I have images from Makena where you can see deer. And so it's better to have the deer and see them on the images than get rid of them. So, or make them look transparent, translucent. Anyway, just hit OK, and that will create the orthomosaic. This part takes a long time, so this might take a couple hours. Well, it says 10 minutes. 7 minutes? Let's see how quick it's gonna... Oh, that was pretty quick. Okay, so the orthomosaic is built. Always save. And then, so we're on the ortho tab already, but we're showing the DEM, which is this. So then we want to show the orthomosaic. So we click that. Wow, that looks really clear. And again, this is not 3D. It's just like a map image, basically, with coordinates. And again, when you mouse over, it'll show the coordinates and the height. So this is actually pretty useful because you can look at your image and you can see the trees and the objects and everything, and you can get the heights of them. So the ground here 335 and the stick here 337, so that's a 6-foot tall dead tree. So let's say I want to see how tall is this little ledge. The top part is 324.6 meters, and down here is 322.9 meters. So less than 4 meters there. Which is actually more than I would think just looking at the image. No, wait. 323, 324. Okay, yeah, it's like less than 1 meter. I think I misremembered one of my numbers, but anyway, this is a very small orthomosaic. And if you want to switch back to the DEM, you can do that. You can go back and forth just with that. And because this is georeferenced, you can overlay it on other data, GPS data, etc. And the way you would do that is by exporting. So you go to File, Export, Export Orthomosaic, and you can also export the DEM. But export orthomosaic, and then always use underscores. Orthomosaic underscore ridge test. But some programs, this is like a relic of DOS and Windows 3.1 and Windows 95. They have problems with spaces and file names. So some GIS programs are still like that. So anyway, I usually use TIFF. You can also do JPEG in different formats. And the TIFFs can be pretty big, so if you have a large area, it might be better to use JPEG. Or if you just want to email the image to somebody or something like that. Because remember, you're still going to have this project, so you can export out a TIFF in the future, or it doesn't, like, this is not your final product. This is just what you're exporting out to use. So anyway, you want to replicate these settings. Leave these alone. These are from the actual data from the last step. Background color doesn't really matter because it's going to do transparency. Oh, and that's one reason to use TIFF rather than JPEG, is TIFF does transparency. You need to write the world file because that gives it geographic coordinates. And your compression, you want to use LZW or pack bits or deflate. It'll compress without losing any quality, so you always want to do that. JPEG quality doesn't matter unless you choose JPEG, but we're doing LZW compression. And then I always use this write big TIFF. Not sure what my reason for that is. I don't remember why I started doing that, but it works. You can also do tiled and it'll split it up, but unless you have a reason to do that, then just do the regular big TIFF. And then you want to definitely save your alpha channel. That's really important, so you don't get like white around the edges. And anyway, oh, you can also change your coordinate system at this step. So you can switch to UTM or Hawaii zone or Hawaii state plane, etc. So I'm sticking with WGS84. And that's it. You can load that into ArcGIS. You can also export the DEM. So again, go to File, Export DEM, and then I'm going to use that same name, but I'm going to change that to DEM. And you have less options. You can't, well, no you don't, you have the same options, but I always use GeoTIFF. If you use JPEG, I don't think that would work right, because GeoTIFF doesn't just have pixel values. It's not like every pixel is red, green, blue, 0 to 255. It has actual values in meters or feet or whatever. And so it would be values from like 200 to 400 meters. Each pixel has one value. It doesn't have color. So TIFF works, and GeoPackage would probably work. I've used that before. GeoPackage works. The other ones, I don't know. I don't know what happens. You can experiment if you want. But anyway, again, similar export menu. The resolution, big TIFF, tile TIFF, world file, and your coordinate system. That's it, you got your GIS products. The other workflow, I guess, that you can do is create a 3D model. So again, you go to workflow and then build mesh. That's going to create a 3D mesh. And it's going to take that dense cloud and it's going to create a 3D model. And arbitrary is what you usually want to use, which means that objects can have undersides. So like a tree is going to have it's 3D in space. It's going to go like that, and it's going to go like that, and you're going to have an underneath. If you did 2.5D, that's like an elevation model where every location has one height. So a tree is going to look like that, and then it's not going to have an underside. It's going to go like that, and then straight down. So I'm not sure what you would use a 2.5D for, because for purposes like that, I guess for ArcGIS Online, you might be able to upload data like that. In GIS world, that's called a TIN, a triangulated something, TIN. But anyway, do the arbitrary 3D. And then face count high. I'll do medium so it goes fast. And then you need your interpolation so there's no gaps. And then you definitely want to have calculate vertex colors so that it'll give you these same colors just as like a preview. More on that after I actually run this. So hit OK. It's going to take less than a minute. One minute left. It increased. It's about halfway now. Almost done. Okay, so 3D model is made. Again, save. Now we gotta switch back to the model tab. And we're still looking at the point cloud, so we're going to switch to the model shaded. And so that's the model with the colors kind of rough. I have the selection tool, so let me not select. So that's the selection. You can also delete stuff off of this, by the way. But anyway, go to the arrow tool so you're not selecting accidentally. And that looks pretty ugly. But this is the low quality model, and it has the colors kind of rough colors, kind of like older video games. Like if you're old enough to remember, like Mario 64, it was just polygons and colors. And I can't, it's not letting me. So hit 5 to go back to perspective. Okay, that's better. I was in the ortho. It was kind of weird. It's still kind of, it's not letting me rotate. But if you hit that drop down right there, it'll let you choose different views. So right now is model shaded, which means it has the colors, estimated colors. You can do solid. And see, that's the plain polygons. So you can see the faces that make up everything. And it's all triangles. Like even these trapezoids you see are just two triangles together. And each triangle is defined by its corners in space. So like that's a corner, that's a corner, that's a corner. Each of those has a coordinate in 3D space. Here's another view. So you do the drop down wireframe. And that probably is what we're familiar with from like movies like Tron and things like that, where you can see the polygons just from the outlines. See, they're all triangles. I guess it's called a mesh because it's literally a mesh. So let me go back to the model confidence. What does that mean? I've never looked at this before. This is kind of cool. It shows you your confidence. I guess 1 is the lowest, 5 is medium, 100 is very high. So the confidence model is pretty, or the confidence values are low for these trees, but really high for the ground, or I guess moderate for the ground. Green is good, so I'll take that. Anyway, go to your model shaded. Oh, see, the low confidence areas are kind of just blurry. So anyway, hit 7 to do your straight down view. 7 and then 5 ortho. This is another step where you would want to delete extraneous stuff. And so I'm gonna use that select tool, but I'm gonna hit the drop down and do freeform. And so you hold down your mouse and it'll let you draw. So I'm gonna draw. Get rid of the splotchy areas where it's not very good. And hit delete. I'm gonna do that again down here. Delete. And of course you can change your view and you can select stuff like that based on height. So sometimes you want to get rid of trees, but I don't want to get rid of trees, so I'm going to click to unselect. I do want to get rid of some of this extraneous stuff below, like and I don't really do much of this because I usually just make the orthomosaic. But you probably have to practice to get good at selecting and deleting. I'm gonna hit 7 to go back to the top down. I'm gonna get rid of more. It's like a haircut. You're giving the 3D model a haircut. And of course, this depends on what your goal is. If you're trying to see vegetation, you wouldn't want to do this, obviously. I think I trimmed too many. I wanted to have the trees along the edge, so I'm going to undo what I did. Undo. And so let me show. That's edit, undo. You can also do Control Z. There we go. And click to unselect. What's interesting is there's little pockets where you can see the ground through the vegetation. So look closely before you delete. Save. Now this is shaded. This is not textures. Textures are the actual images that get mapped onto the face of 3D models. Faces. So, like for example, in video games, if there's a pattern, like in a lot of games you can buy skins, and part of those skins is just images. It's not like actual 3D stuff. It's just like a pattern on your clothes or whatever. Or in a lot of games you can choose your face and things like that, and you're choosing it's basically two-dimensional art or photos that get projected onto that 3D model. And so we want to build those textures, and what's good is we have photos to build those textures from, and so that's a part of your workflow. So you get a workflow, build texture, and then you have a few options. These are not the defaults. I don't remember what they were by default, but you definitely want that whole filling. And just like the orthomosaic, you can do ghosting filter. I usually don't, but generic makes it really 3D, so that like trees will have undersides, etc. And of course your sources, your images. If you just did 3D model, I think it would just use what's there, the estimated color. And then blending, you want to use mosaic, I think, usually. I don't think I've tried the others. And then your size and your count. Each image is going to be that, and there's going to be this many of them. So you're making 8 images, and each one has that 8000 resolution, 8192. And you want to use multiples of like 1024, which are like based on binary. It's kind of like resolutions on a screen. Like computers used to be like multiples of 8 for the resolutions before high definition, like 1280 by 1024 and things like that. But anyway, you want to stick with numbers like that. Just do like 1024 times whatever, and in this case it would be times 8. And you'll have to experiment and see what works well. But I'm just going to do 8192, and I'm going to do 4 images. And it basically creates textures for everything, and it puts them into that 8192 by 8192 frame, and it'll use however many you set it to use. And you probably don't want to go higher than that 8192. I think I've tried 16, what is it, would be 16384, and I think my computer crashed. So you can go lower than this and increase your count. Anyway, this will make sense when I actually run this. So I'm doing 4 and 8192 and letting it build. This might take a while. 4096 is the width of a 4K video, which is why it's called 4K. Or 3840 is what TVs usually are, but like actual movie 4K is 4096, which is half this 8192. So again, it's a multiple of 1024. It's gonna take a while, a minute and a half. Okay, so once you have the texture built, you have to again change your view. So hit that drop down and go to Model Textured. I think it'll take some time. It's the big hourglass. Oh, there we go. Oh, I forgot to save. Always save. Look at that. So the trees are not great. I have the selection still selected. So let me click to unselect and then switch back to the arrow. Okay, now I can drag my view without selecting anything. And you can see there's a lot of stuff that you can see that you couldn't on the dense cloud. For example, look at these little rills, probably from water flowing down this slope. And because it's 3D, you can see things that you couldn't see on the orthomosaic. Like this is a vertical face, and you can see like roots and dark soil. You can see what's there. And if I had flown angles more horizontal, where the camera was pointed straight at that wall, it would look a lot better. But I only flew really looking down and looking down at an angle, not even 45 degrees. So this is pretty good considering. But you know, if you're on a slope like this, you want to go down low. Be careful about hitting the trees, but go low and get the side angles. If you're trying to capture trees and slopes and steep gullies and things like that. But look at that, you can see that you can see the soil layers pretty well. Like you can see that topsoil, really light color, and then you have the darker stuff underneath. And over here you can really see some strata. Here you can really see layers. And then your trees and things, you know, they don't look that great, but it kind of is what it is. Like imagine if the trees were like really accurate. You would have, you know, your polygons would be, you'd have billions of polygons probably. But you can see too, there's some weird little artifacts. Like there's this floating sphere right there. So you can delete that kind of thing, clean up the model. That might be hard because when you select, you're selecting what's behind also. But so it might take a lot of work. I'm trying to get it downward. Oh, there we go. So you can see the trees, kind of. They look kind of blobby, but you can see them. This part probably should have a stick or a stem coming out this way, but you just have the sticks. The branches look like sticks. But the ground comes out great. And remember, I just did a medium quality mesh. So if you did high, it would look nicer, your mist. And then you can export this. So again, go to File, Export. Where is it? Export model. And then usually you would use OBJ. That seems like a standard now. And there are various places where you can upload these. And it'll create the texture and everything too. So let me do that so you can see the texture. So I'm going to call this model Ridge Demo. And export this to the same folder. And usually you would do your models with local coordinates, so it's not going to be like WGS84 because it's not for GIS. And I have tried doing it with coordinates, but I haven't had success using those files. So just use the local, and then you can view them in different programs. If you want to experiment, you can, but and you can have a comment on your. I just put my name, and then usually you want to use JPEG. You don't need to do TIFF just for textures. And then keep the vertex colors just so your software that you import to can have a reference if the textures don't work or whatever. I don't know what UDIM is, but always save that alpha channel. And then precision 6, that's the default, and that's what I've always used. I'm not sure. I guess that's about precision of all of your polygon vertices in space, probably in meters. So maybe you can, if you need more precision or less precision, you can change that, but 6 is the default. So export that. And then I am going to, let's see, no, A drive. Working 3D, Ridge Demo. Now I should have put the model in a different folder, but this is the one with all my images. But you can see the textures, what the textures look like. Now remember, I made 4 textures, each on 8192, and that's what that is. And that, and that, and that. So there are my textures. So you can see, this is basically what we saw, but it's all pieced together. It's not like the 3D model. And it has these areas that it maps onto the 3D model, and somehow it knows what to put where. So that's kind of interesting to look at. And then there's some black spots. But yeah, so that would give you an idea of what these actually are. And so I've got, you know, all of the textures that are on that model are in this file. And it's not useful on its own, it's only useful with the model. We could also look at the orthomosaic. It won't work. I guess you have to open it in GIS software, but actually I can do that. Let me update available. This is my day gecko art. So I have a tab in my project that is, the coordinate system is WGS84, so that's why it's called that. Okay, so this is a different orthomosaic of the industrial park. But and you need both of these files, the TIFF and the TFW. So I'm gonna put that into, oops, wrong program. Drag that TIFF. Is it loading? Yes. And then you can right click and then zoom to. And it looks really ugly. And there you can see it's overlaid on the satellite photo. But when you load into ArcMap, they usually look weird. Or ArcGIS Pro. So you right click and go to symbology. And by default, for some reason, it does this percent clip. So set to none, and I set my gamma to 1. It's an annoyance, but that shows the actual image. And then you can see you have your 3 bands, and your alpha, your transparency is band 4. So that makes it so you don't have white on the edges. Or you can have an irregular shape and it won't have white. But there we can see, let's see how it compares to the base map. It's close. Now this is GPS off the drone, so it's not survey grade. It's probably 10 or 20 meters off, so let me see if I can find an object to measure. So that's my image. Yeah, it looks like, well, I can't tell what's what. Looks like that piece there is that. So if I measure tool, and I go from that little promontory to there, 31 feet. So I'm 10 meters off. But you can georeference this to make it match up. So that's like a whole nother video that I could do. But if you're just using it as a reference for itself, it's fine like this, or you can georeference it. Or you can, in your Agisoft project, you can have ground control points, which will make it a lot more accurate. And those ground control points are usually from GPS, or they can be surveyed, or they can be off of existing imagery. But I don't want to get into that with this video. So that's about it. Don't forget to save your project and back up your files. If you have the images, you can always recreate your project. So make sure your images are backed up, definitely. And also your project. But the images, really important to back up. Put them in a safe place, burn them to a Blu-ray, archival quality Blu-ray,